Hello and welcome. I'm Bill Wake. We're here working on a program to compare tunes for similarity, and lately we've been working on clustering so that similar tunes are grouped together and less similar tunes are grouped further away using what's called dendograms. And we've got some cleanup to do. We got through, I think we have everything working, or at least as far as we understand we do, to produce a dendogram. We don't yet have it working with actual tunes. We just have used numbers because they've been easy to compare and set up and do things with. But there's work to do. Okay, let's see. I just ran tests. Everything looks green. That's good. Let's see if I turn this on. Okay, so cleanup, connector, and clustering. Well, let's see. Where is connector? Oh, it's in cluster. Okay, so I've got a few things I see going on, and I want to make that happen, and then I think that'll open up other things. Okay, first thing is this leg concept and the connector concept, they really are. They're really not the same as cluster. So these are more they're domain concepts in the sense that they're what gets drawn on a tree to show the dendogram. I think we have a reasonable example to show. All right, so let's take cluster and select. All right, so here's the dendogram. This tells me that 1 and 2, they have they're both leaves and they've got a pretty similar grouping here. Okay, I think that's about 3/4 if I remember how we hard coded things. And 7 and 8 are close, and 10 and 11 are close. But notice that 7 and 8 are closer to 10 and 11 than they are to 1 and 2. So these get grouped and so on. And what the connector is basically it's the data that lets us draw this line, or possibly this one. We don't have a good, well, this one's unbalanced. Okay, this leg's longer than this leg, and then it connects to the rest of the dendogram. Okay, and so what we want to do is kind of get this thing, the dendogram as a representation with its lengths and so on is reflecting the cluster. I mean, it is trying to show the cluster. And so there's data about the cluster and information about the cluster, who goes with what, all that kind of stuff is part of the cluster. But I think this connector stuff is not. It's really, if we were showing a different view, maybe like a Venn diagram kind of view or something with things closer and closer, bubbles or something, we'd have totally different data in our, whatever the equivalent of connectors would be. So I think we want to pull that concept out away from the cluster. Now, the other thing I thought about this weekend is kind of philological wordplay kind of thing. But the word dendogram, dendo comes from a Greek word for tree, and gram for picture or writing or something like that. We finally named these legs, which was a good move, but I think they're actually branches if this is a tree structure. So we may do some renaming there too. But first thing is I want to get this out. Okay, I want connector to be its own deal. All right. And so let's deal with that structure thing. I think I'll keep it in the clustering area because it's part of that transformation, but a separate file would be an improvement. Okay, so let's cut this out. New file. This will be connector. And we're not using these opening comments. I should delete them somehow. All right, but sequence number and leg, they're both part of, they're both coming from up here. And level, I think also. Cluster Oh, cluster does have level. Let's undo that. Let's move this one up. These two down. Connector. Okay, cluster. Oh, interesting. He does have sequence number. Right. That is generated by the cluster algorithm. That's true. All right. Okay. That should be fine. He will find it once he figures out how to compile things. Yeah, it doesn't sound likely to be a problem. Okay. Let's commit this. So we pull connector and leg to a separate file. And that's a refactoring. Everything in Xcode more or less is manual, I guess, refactorings. Okay, now cluster. The thing I want to do now is I want to find those pieces that are used by, whoops. I have videos that I've had open for a while, and I think they wake up after a while. Okay, let's see. So I want to find methods that are not used in the clustering algorithm, but really are used by the connector algorithm. Okay, and like connectors is a prime example. Starting row, he does some stuff from the cluster, but everything about him is about producing connectors, and so I think that's going to be a separate thing. All right, now where can I put this algorithm? Well, I guess I was wondering about this thing. Let's pull this into a new class. So lots of times you have an array of stuff. It probably should be its own class. And I think if we do that, that'll give us a place to put this. So I may regret it, but for now I'm going to put it over here. All right, so I'm going to make type alias connectors equals array of connector. Okay. And let's get that in use. I don't think it's going to last long as a type alias, but it should be fine for now. Uses an internal type. Oops. Okay, now, well, some of these are connector tests, really. Let's pull those over too. Okay, so somewhere we have cluster tests. Let's make connector tests. And they really belong in shared, which makes me wonder if my connector, oh, I did, okay. All right, so connector tests, anything about clusters, I'm sorry, connectors, I'm going to pull over. Well, that's not really connector per se. Okay, now these centers. I kind of suspect it's not. I kind of suspect it belongs over on cluster. I'm sorry, connector. Two words that start with C, what can go wrong? All right. And these tests should all run. I think that message is old. Okay. Extract connector tests from cluster tests. All right, now our cluster with this connectors. This is recursive, right? Yeah. Okay. I want to get this pulled over. I think it's... Let's start pulling it over and see what we get. All right, so I don't... Where's that going to live? Well... I'm going to switch this now. I'm going to make it a struct connectors. Okay, let's do that first. Our contents of that type. Okay, now anybody who asks for connectors and iterates over them is going to have to do connector.contents. All right, and let's see who breaks, because there's going to be people breaking. Okay, requires connectors. All right, I don't think... I don't think I'm going to like this long term, but let's see what happens. Okay, so let's return this being connectors of empty list. All right, and so connectors needs an init. Oh, it volunteered. Contents connector, self-contents equals contents. Good. All right. Yeah, I don't think I need to make that a public name. It's kind of the only thing in there. Okay. Okay, connectors.append. Okay, well, append contents of. Oh, we're definitely going to make some changes. This is getting the structure there. So append contents of, and this is array of connector. We're going to say contents equal contents dot append contents of public func. So I'm going to have to make this a class. I guess I don't have to in a way, but I'm going to let it shake out that way. Type O. Okay. It's append contents of, and then this is append one connector. Maybe I'll make this items. Or connectors. Would that be better? Oh, well, this is actually connectors is returning a connector. So let's take that in instead. Public of contents of connectors of type connectors. Connectors.contents. Okay, and this is of a connector. Good. Hey, can I extend array? I guess theoretically I could. Yeah. It would be kind of an intermediate way. Would it be better? I think by the time I do these differently. Would that be better? Well, I feel like if I get it wrapped up in its own class, it's going to be easier to control, but we'll keep that idea in our back pocket, I think. Yeah. Hi. Yeah. I mean, I hate redoing append and all that. I mean, theoretically, I could make this thing a collection. I may have to, if I want to get rid of the contents variable. But I think I'll keep this going this direction because I do think it will become more of an independent object as it grows. And even this, I guess this would still be array. Probably does it by default. Yeah. We'll keep it in mind because if I don't need all this, then it would be simpler to not have it for sure. Okay. Tests all ran, and let's just run because some of this was interesting. I guess it's not mutated in the sense that it's holding the same object, but the object it contains is being modified. But that's normal for a class as opposed to the array of connector it was before. Okay, I'll run again. Okay, tests are passing. That's running. I think we'll say we're good. So we made connectors an object instead of a type alias. Okay, now on cluster, all of this is because I want to get this out of here. Oh boy. All right, I would love to get this function over there. Connectors. And it's almost more of a static. Let's see, who calls this initializer? I think it's only one place. Right. Okay, let's take that one off. Something odd there. Did my test not run before? Something's really weird. Let me put this back for a moment. Okay, well that one will go back to what it was. Yeah, I think our connector test did not run before we checked in there. Connectors is not equatable. Although connector is, so I think we could just say it's equatable and get one generated for us. That would help. Well, I'm going to make this optional. And not use it here. Okay. Count. This is where I don't like making contents available because everybody's going to know about it. Well, I guess these 10 places, whoops, will have to change again if we get rid of that. And we're still making the array visible. All right, so you should be offering. We're going to return LHS. All tests should pass. Okay. Don't know what ran. Yeah, I think we definitely are seeing that here. All right. Let's see. So we, made cluster tests use contents. Yeah, just use contents. Okay. All right. Now, I do think going back to this, there should only be one place that uses content, uses this. Right, that thing. Okay, and we're defaulting it to that. So I think that constructor is unnecessary because they're always start empty and then get stuff added in. All right. So that should be a good refactoring. Okay, so remove unneeded constructor. Okay. Now, this cluster stuff. Connectors. If I gave you that, I think you would have to tell me the cluster. Okay, so let's kind of install this method over here. And it's going to be static. And it's got to pass an argument, which is a cluster. Okay. And I think cluster of E. Is that going to need... That's going to make this generic as well. E has to be equatable and hashable. Okay. Well, I think you're just not caught up. Okay, and I'm going to name it. Am I going to name it? Well, let's see if it builds. E does not conform to hashable. I think you're wrong there. We said E does conform to hashable. Now I can believe there's things out there that don't reference the generic. Okay, yeah, that can pass in E. Especially with too few type parameters. Is it and? Convert value of and. Okay, I think this is progress. So this is really cluster.connectors 0. So we're trying to call this method. Okay, let's build. No one is calling it yet, so there's no real danger. Okay, testing. Yeah. All right. So we're pulling connectors from cluster. Okay. And I'm going to rename that too. I'm going to make it make or build. Go back and forth a little bit on that. But what we're saying is I want you to build the set of connectors or the list of connectors from this cluster. And you're going to do that by calling the old method. So now I want to find whoever calls this, like, well, I guess I could just search. I could break it and let the compiler tell me, but here's the places that call cluster connectors. I want them to call clusters.connectors with passing the cluster in. So I'm going to flip those. Okay, so this one, instead of that, it's going to be connectors.connector.build for C1. Okay, that should pass. This was C3. Let's pull the C3 in here first. Connectors.build for C3. C5. Okay, C5. Connectors.build. C5 again. And C1. Okay, that should all pass. We'll do this last one in a moment. Okay, and then this one, we're going to do cluster. Connector.build with cluster. Okay, let's run that one. Good. All right, and so use connectors.build instead of cluster.connectors. Okay, so I'm doing really small bytes, but I am getting this thing out of there. So now I don't think anybody references this. Okay. So that piece is there. Now we need the recursive one. Now, I think this is still part of make. All right, I'm going to copy first. Okay, connector. Okay, he's going to need a cluster of cluster of E and starting row, and what was self is now cluster. Okay, any more selves? But I think he's going to be static as well. Okay. Okay, so that should build. No one's calling it. And I'll ask who's calling this. Should be one place in a bunch of tests. Okay, well, one. Nobody's calling that directly. They're only calling the other one. Okay, well, that's even better, I guess. Connector. Yeah, so we're definitely getting them pulled out of there. Connector. Well, that's on our connectors class. Okay, good. So I think this is now private function connectors. And this is zero. Okay, so now when you ask me to build a set of connectors from a given cluster, I say, okay, well, what I'm going to do is delegate that to this function that takes the starting row and it takes the cluster in the starting row, does that. So this should all pass. And the tests we're all calling cluster.connector.build, so they don't care. That's more of an implementation. All right. So now this should be able to come out. Okay. Interesting. Where's your problem? C1.connectors. All right. Why did you work before? Xcode, what's the deal here? Cluster has no member connector. Oh, it does not. Yeah. C1 is a cluster. Oh, this is a bit ugly. Or, I don't know. I think it's going to be inconsistent. C2.connectors. Okay, we definitely don't want to do that. We want to do C1, C2, but connectors. Okay, so the result, this is where it's a little weird. Result is a connectors. Append, that's our append method with contents of, and then we're appending cluster, and result is a connectors. So that's what's returned. Okay, and it's connectors. I should say it that way. Okay. Let's make sure that's still good. So I guess I was going backwards into the old version before. So now I can remove this, and it should really be removed. Somebody should have complained that the function wasn't there, though. I think Xcode's they run the checkers somewhat independently, so sometimes you don't get the error until a few seconds late. All right, but that is good. Okay, so we refactored. We move cluster.connectors over to connectors. Okay. And is our cluster ignorant of this stuff? Well, I don't know who asks for elements. That could be a lot of places. Cluster does. Connector does. Well, okay, that's the recursive one. The center. Well, okay, connector does. Proximity matrix does. Okay, that's a clustering thing. Excuse me. All right, but this method, it's returning the y-axis for our cluster, our connectors. Okay, and so I think I don't know where I want to put this. I mean, it really is part of the dendogram stuff, not the clustering itself. Well, all it's talking to is a cluster and row number. Let's see who calls this. Yeah. Find selected symbol. Okay, connector does. All right, let's put it on connector. It's a little odd to be there, I think, but okay, so he has no access to self. He's going to have cluster of E. Okay, and this is going to be cluster dot elements dot count. That sounds a little weird to me. All right, but sometimes you just do it mechanically. All right, now element. Okay, that means we have to be connector of E, where E is equatable and hashable. Okay, so it can be a cluster of E, connector of E. Oh, we don't want to switch on self, we want to switch on cluster. Okay. Cluster has these? Yes. Okay. The cluster tests probably need to be connector tests. E cannot be inferred. That should be E. I think he figured it out there. Okay. I mean, what's interesting to me is nobody's calling this one yet. Connector, cluster of int. This is a helper function in dendogram view. Okay, I may be regretting that int there at some point. Oh, that's our example, isn't it? Oh, I'm not sure. Okay. Yeah, I think we will regret the int here and everything that follows from that. Okay, but we're getting through a different problem. All right, so now center. I don't think anybody calls this one, so let's do this and run tests. Oh, they do. Okay. Okay, they are calling it, so that's kind of good. Run tests. Cluster E. Well, that's not really true, is it? We still have that there. Okay, did that go away? Yes. Okay. So I think we have center. Some people are using it. Let's see who uses connector center. Sorry, cluster center. Have I been commenting out the wrong one? Yes, I have. Okay. All right. So who uses this one? We want to switch them over to connectors. Okay, center. C1.center. Okay, let's move these tests over to cluster tests, connector tests. Okay, so he's clustering an element. Okay, so we want this to be element 1. And I'm going to make a new connector. Can I make an empty one? Not really. Okay, let's make this static. Which he kind of is, because he's really pulling stuff from this object more than anything. On connector. Sorry, connector test. At no point creating a connector to establish that. You're right, thank you. Okay, those should be working. And then connector. There's the definition in cluster, and here we want the one from this. So we're going to take connector. Of C1. And C2. Okay, and then cluster can get rid of this. Okay, now what's left? Elements we decided we did need for other reasons. Sequence number, level. I'm going to pull this down just as a physical rearrangement here. These others seem more conceptually tied to their arguments to me, so this one's more of a, I don't know, more of a function of the whole cluster. Okay. This, I believe, is back to where cluster was before we started connectors. All right, so that should be no problem. All right. So I'm good with cluster. I think that'll work. He's simple again. All right. So I think we're done with cluster. Connector is still, well, I'm at least going to pull this to a different file. Connectors. Connector has this helper. Who sees? I guess the callers do see this. Okay. That should build and run. Okay. Well, I still don't know why we're calling twice, but we'll see. Okay. And then, all right, I guess what I wonder is, who uses this? I think it could be local. Yes. And the same thing here. Yep. All right. Now, connector. So, well, one thing I said was, we just taking the metaphor of dendogram. Dendo is tree, so I think we're going to call this branch instead of leg. We'll try it, and if we hate it, we'll change it back. Okay, and then here, I'm just going to say top and bottom. I usually prefer names that don't embed the type in them because I change type names. All right, and that should be a neutral change. Oh, these things. Xcode's got some bug in its rename. The latest version of Xcode is messing me up with it. right. I guess that's really the rename. Leg to branch. Okay, I'm going to leave off cluster. I think we're done testing it for now. Okay, now connector. So I'm a little puzzled. This thing, it just strikes me odd that we don't have the X position in here, and I think it would make things nicer. Like we know the starting point is XY and the length is double, right? It should make something easier. Let's see. So that was used in cluster view. No, dendogram view. Let's hide that one for now and that one. All right, what are we doing? Clean up connector and clustering. Okay, I guess that's what we're doing still. All right, dendogram view. He has to calculate stuff. So his top line, we pass in X and this Y and the function of the length and a delta. Minus 2.25 times Y scale. That adjustment is because of the width of our buttons. Ugh. These X's are the same, so at some level, okay. Yeah, it's calculated from level. I don't think it's horrible. It just seems odd. Like if you gave it everything in the branch, we could have a little helper function that took a branch and drew it. Okay. And maybe takes two branches for this one. For this one, the bottom one. It goes from top X changes 0. It's drawing the vertical line there. This is like the joint or the connector line. So when I calculate branch, where do I calculate branch, right? Somebody else is doing that, which was connectors. Here's connector. Level. Okay, there's two things going on as usual. One thing is this X position is probably useful here, even though it's the same in both. And in both, it's really 1 minus level. Where's that view? Here, this X is a function of, it's the frame width, which is definitely a view concern, times 1 minus level. So I think you could say our X position is 1 minus the level of the connector, which you seem to have here, where's the connector coming in? Sorry, the cluster. We know whether we're talking about C1 or C2. Okay, so okay, so I want to get X in here. And trying to think of an easy way to do this. But it should be 1 minus level in both cases, because it's using X the same consistently there. So I'm going to add it and then not use it and see how that goes. Okay, so I'm going to add X of double. All right, and then a lot of places should complain that they don't have X. Oh, interesting. Oh no, people should be complaining. See, this is weird. Okay, X is 1.0 minus level for both branches. Okay, so now we have it in this function. It should break on other callers, yes. Okay. X is, well, in this case, it's 1 minus level is 0.25. X is 0.25. X is the same. This is 0.125. Okay. Level 0.5, so it's 0.5. And this one's 0.75, so 0.25 is right. This will be uglier. 0.25, 0.25. He's the same, level 0.75. This is the same. This is our 0.125. Level 1, so X is 0. All right, I think I got them all. We'll see about those later. Okay, I don't know. It's not terrible to me. Branch. Well, maybe I'll make them. You sort of have two ways you can do it. One is to do the arguments, each one, and I don't think that'll hurt the readability of this, although I suspect it's a little redundant. Kent Beck had a book on Smalltalk guidelines, and I remember this style being in there, you know, one line per thing. And I think he generally used it. I don't know if he'd use it for one argument functions or even two argument ones, but long ones definitely. Can't remember enough. I was never a real Smalltalk programmer. I learned it kind of a couple times. Used it for some toy things, but nothing really professionally. But I remember I was working at Digital Deck back in the day, and they were first doing workstations, and they were the ones we had were slow. And oh, thanks. You'd move your mouse, and you know it would turn into a little movie circle or whatever the little icon was to show it was thinking while it did it. And then I went over to the 286 to work on Smalltalk, and you know, you've got these animations and things bouncing all around the screen and all this stuff on a PC instead of the expensive workstation. Yeah, I think it does make things better. Like you get a better comparison of the top and bottom. You know, it's easier to see that they're different or not. But it's kind of a pain to have to go through and do it. On the other hand, maybe you could get your formatter to do it for you. That'd be nice. Okay, so we are added X to branch, but not using it yet. Okay, now there's something else about this. We went to a fair bit of trouble to make X be in the range 0 to 1.0. Nothing expresses that here, so I kind of want to do that. And that's, I believe that's coming from the cluster. So I said I was done with cluster, but I am not. Level. Okay. Level comes in. Let's see usages. Okay, level's the second argument always. So these are lots of zeros. Well, elements, the level is usually 0, right? That seems, I think not a test. How about this one? Not relevant. Dendogram view. That's my example. Oh, there's some. Yeah, okay. I don't know if we really... That's the test, but there's nothing in priority element that does it. I don't know. See, I think this will always be 0 to 1 the way we are working, because our similarities are always 0 to 1. Yeah, that's also seems to be true, right? That an element should never be different than itself. That the level should be 0. So let me bring up that Wikipedia. That was hierarchical clustering. Excuse me. We were doing single linkage. Excuse me. The disjoint clustering has level 0. Yeah, I don't think Okay, quite a distance is minimum of distance. Right, d of ij, that's your pairwise distance. Okay, so the level of an element is going to be 0, and then the level of, the distance of two clusters is this, and then where's LM? LM is always a distance. Okay, so if our distances are always 0 to 1, then our level is always 0 to 1. Okay, and so I think I'd have to go through more closely. Most of these tests use 0 for elements, and I think, like you said, that probably should always be 0. This is funny to me. From 1 to 2 is 2. That's a function of that. Yeah, I think this example is actually, well, okay. No, I think this should be a 0. I don't think there's any meaning to it. Man, are those still out there? No, it's an old. Okay, so I think you're right that these ones that have non-zero are probably, they're probably not meaningful. I don't think anybody really cares about their level because we compare single elements by their distance function. Okay, I'll do them one at a time. One test at a time, I should say. Okay. And we know we're looking at that last argument. So my hope is we get this away. We're going to simplify things more. Okay, 3, 4, 5. That should be that line. All right. Okay, so make level always 0 on an element. All right, and then now we don't need that argument. Okay, so element is cluster. Right, so I'm going to take this off. Well, no, let's do it this way. If you ask for the level of an element, it should return 0. And if you ask for a cluster, whoops, it should return what it always did. Return the level. Okay. Okay, that should be working. Ooh. Level 0, 0. C2. Okay, I did this before too in some of the tests. Let's rename this E1. E2. E3. Okay. Well, this is C1. He's the actual cluster. Okay, E2's level should not be 0.5. I missed that one. Should be 0 and 0. Mutable valuable level was never used. Yeah, that's what we're going to do in a minute. Trailing white space. I think the editor just messed it up. Okay, so now we don't need a level because it's always 0. Kind of wish I'd recognized that earlier, but oh well. So level. Okay, we don't need level. Well, I don't need any of these now. A bunch of tests should be, yeah. Okay, now we take these out of elements. That's a cluster. And I wish I had IntelliJ level refactorings here because that should have been caught a long time ago. Well, it would just do it automatically and be simple. Extra argument. Elements. Trying to figure out if I've got a faster way to edit this thing, but I don't really. Oops. Yeah. Yeah, I don't think any. I guess somebody else could, but that depends on the distance table. But the elements themselves should always be 0 at this point. All right. Okay, this is more tests. I didn't like my switch formatting. Okay, we'll fix that too. Element. Okay, so we move level from cluster.element. It's always 0.0. Well, anyway, back to connector. I think we will always give a value 0 to 1. It depends on our distance calculation, so maybe I should go back. Cluster, oh, maybe it's priority matrix. Distance from cluster 1 to cluster 2. Oh, that's the function that comes in. Okay, we haven't dealt with this one for real yet. Let's find callers of this. Interesting. Okay, we're not using this in production yet because we aren't doing tunes yet. We've only tested it with numbers. And that function is not a unity function because it's taking differences of integers. Okay. Which is not in general, I don't think it's a problem per se. No, somebody's got to be asking for the max or something. Like elements. No, min. Oh, oh, no. Where's min in that? Min count 1, count 2. That's Parsons code. Priority matrix max. Oh, I didn't do a text search. Ugh. Okay, all kinds of people do. Proximity matrix, that's the one we probably care about. Okay, find the biggest sequence number. I guess that's not relevant. Yeah. Okay. Maybe we just don't care. We're given X and Y. We're given a length. All right. So now we want to use X in the dendogram view. So this well, this is really frame width times connector.x. And now, like you said, sometimes this reveals more if it's separate lines. I think this kind of will. Or maybe connector.x. Oops, sorry. Well, this should be, we set X to this in each case in our connector. Where would that be done? Right here. This one. So we put 1 minus level in our X on the branch. Now, I don't know why dendogram view can't see it. Connector.x. Yeah, I'm anticipating that connector frame width and Y scale are going to be arguments to this line eventually, and maybe more going on. Why are you not seeing that? I'm going to do a rebuild. This is connector. Yeah. Okay. So, no. Connector has no member. Oh, it's connector.top.x. And this is frame width times connector.bottom.x. Okay. And then this, I'm going to use top. Times connector.top.x. Now, this distance function may have been a touch too cute. I'm sorry, the deltas, maybe that's not worth it, but yeah. Okay, let's run this. Okay, that's all still looking good. Let's somehow think of this function. It's really I have another idea too. Maybe I should have been doing that before this, because I think I'm going to demonstrate that there's a problem in the way I do this. My idea was, well, why not flip this so the cluster, the elements are on the left, and this part is flipped horizontally. It would seem a lot simpler, and it also seems a lot more you're kind of concerned about the elements working your way up, which ones are more similar than you are about starting at the top and working your way down. So I kind of want to do that at some point. So let me put that in the to do. And I feel like I'm multiplying by -1s and stuff a little more than I should because of that. All right, so this is flip dendogram horizontally. Okay, and I think that'll be a good thing at some point. All right, so I think if you drew a horizontal line, well, what's frame width, right? That's coming in. There's... All right, does frame width need to come in? Where is it coming from? It seems like it should be constant for any given picture. Find usages. Proxy.size.width. Oh, it's not. It is for a given proxy. Well, I'll tell you what I was resisting. What I was resisting was having to repeat frame width and scale Y in my argument list. Proxy width. Well, it is true. That will always be that. Sorry. I'm bad. I always like to shuffle around when I'm thinking. Not so great to follow along visually. Yeah, proxy size width. You're right. It always is 1,000. Because that's coming from here. Let's pull this frame width. I think it was 900. And that's kind of going to change too, but that's fine. Is it int versus float? I don't know if that'll be enough for it. Okay. Yeah, so now frame width, let's put that in here. Proxy.size.width. Okay, so we think any proxy.size.width should be frame width. Yeah, I don't think I do necessarily. Or I guess if I do, I'm willing to pay the price later to use it. What is that? Unused parameter. Oh, yes, I don't need proxy anymore, so I don't need geometry reader. I've learned the hard way to delete this from the bottom to the top and then reformat. Okay. That should run. Uh-oh. Oh, that's okay. Gotta click select. All right. That seems okay. Okay, so I think that's just... he's just confused. Okay, let's see. So remove geometry reader and just use a constant for frame width and height. Okay. Now, I don't think I need... There's no reason I should pass frame width to cluster anymore. Okay, so let's take that out. He should just use the normal one, and the color's down here. Oh, he's... diagram percent. Okay. Now I think you can do this in Swift. And it'll do the right thing. I don't care for it particularly, but I think it does work. Let's make sure about that. And again, we're fooling with a view that we haven't really tested separately. So, okay, then that seems okay. If it weren't working, it would have drawn across the whole thing. And I think if I leave it out, it will draw across the whole thing. But I do have to be careful when I work with it. So this, I believe this would draw our clusters the width of the screen instead of the selected area. Yeah. Okay. Now, does anybody use X? No. Okay. So this, I think I want to make it be horizontal line. Like, what if I made vertical line and horizontal line? Okay, so let's do that. Horizontal line, you got to give me X. Well, we're going to pass in a connector. Dot. No, we're going to pass in a branch. And it's going to draw it. Okay. So connector top, connector top, connector top, Y scale. Okay. So, I'm going to need that stupid diagram percent. Or I'm going to have to do this in advance. He's not really a percent, is he? Yeah. Oh, he does use X. Okay, let's fix that. Okay. Now I do horizontal line. Well, I need connector. I guess I need diagram percent. Well, I don't. I don't know. Let's put the branch in. We'll get it working and then figure out some of this stuff. Okay, so there, I'm going to do a line. And it's frame width times diagram percent times branch dot x. Okay. And then it's this. Now, why is 2, 3, 4? Oh, yeah, I'm working on it. This is branch dot y. This is that mess. And 0. Okay. But frame width is really frame width times diagram percent times branch dot length. This is 1 minus diagram percent. No, it's not, is it? That's really a function of button size. Okay. Horizontal line is unused. It doesn't return. Oh, it does return some shape. Okay. All right. So that thing is line of connector.top. Sorry, horizontal line of connector.top. Yeah, we're gonna have to do something about this button size thing. It's still in flux in my mind, honestly, but let's at least make a constant for it. It actually, I'm really not totally happy. This should run. If you see these things, I'd like them to be circles, but they look like little stretched out capsules. So there's something going on there. And then I don't really want that text in there. I really want, well, I've been thinking about that one. I think I want diamond inset filled. But this 0.25 is really, it's really because we got one character wide and the Y scale is actually it's supposed to be a circle of the height and width. So it was a little bit dynamic, but it's a function of the width of the button. And because the Y scale is tied to the, where is that set? Font size. Now, why is that a quarter? I don't remember. But let's get the constant out, and I'll call it what, button allowance or something. Button width. Now, button radius maybe. Ratio. I don't know the right word for these things. When I called it percent above, it's not really a percent. I'm going to stick with percent, even though they're not true percents. Constant for button size. Yeah, well, it's 0.25 times the line width. So the line width is 4 times, the button is 4 times the line width. That doesn't sound, I don't know where that comes from. All right, but in any case, button radius percent. Yes, you can. All right. So I'm calling horizontal line connector.top. Everything in here is connector.top and constants or semi-constants. If I take this one out, everything should still work and look the same. Oh, I did misspell it. Okay. Okay. Whoops. Wrong one. All right. So the horizontal line is still looking good. I definitely think that's an improvement. Certainly at the point of call. Now this one should be horizontal line connector dot bottom. I'm feeling more confident, so let me, everything's connector dot bottom, yeah. Run this. Okay, good. And then this is vertical line. So let's make that. And he's kind of going to be similar, I guess. Branch. No, he's really connector, isn't he? Top X, top Y. He's really the two branches. Okay, so this one is frame width times connector dot top X. Frame width times diagram percent here times branch dot top X. Y scale times top Y. This one's a 0. Delta X. And then this one is Y scale. Well, let's put this in and then we'll work it out. Y scale times bottom minus top. And so this is vertical line. Okay. Oh, that makes that group look a lot nicer to read, doesn't it? Okay, and looks good. All right. So add methods for horizontal and vertical lines for branch. Alrighty, now this. Oh yeah, there it is. The 0.5. Yeah, so okay, the 0.25 is really this times a half because we want from the center of the button to the edge. Okay, but I think I want to work on this button a touch and then work on these scales. All this scale stuff to me, it sort of says I don't know, the flipping back and around and percents, that to me says I'm missing a level of view, I think. All right, so the thought I had was this should be a system name diamond.inset.filled. Okay. Now the radius stuff is going to mess up. Okay. Oh, I should use the image. That's what it is. I think our lines are going to be a little screwed up now because they don't relate. Oh, they're in the button. Oh, I don't like that look. I don't think that's, well, that image is not centered. The size of it is not great. Maybe I'm doing that to myself. Maybe I should just do font size. I don't know. I wonder if a button is the right guy to work with here. Yeah. Okay. So my thought on this thing, let's just take font size. That's much cleaner. My thinking is it's kind of a combo tool. And I'm not sure the semantics I want exactly, which doesn't help things. But my feeling is clicking on this node. Oh gosh. Well, we're going to have to work on it. But clicking on that node, I mean, actually the horizontal, excuse me. It looks a touch off. I'd like it to just touch that edge of that diamond. Yeah, we don't really need that circle. I almost wonder if I'd be better off with just an image with an on touch or whatever the right qualifier is there, and lose the button. The width is all based on the image. The position is correct, or needs to be dealt with. What's the diamond look like on the other side? Oh, it never concerns itself there. Okay, it gets cut off on the top and it's a little short on the bottom. I might have to offset it vertically a little bit just to account for the diamond. But my thought was, if you click a diamond, you're automatically selecting all the diamonds, all the nodes beneath it, and clearing the others. So if I clicked here, I would like this to turn into an empty diamond, empty, full, full, full. And here everything's full, and here it's just this one. I'd like it to bold these if they're selected. And if you click a node that's already selected, I don't want to change. But I'm trying to evoke the sense of it's sort of like a radio button, but it's sort of like a checkbox, an automatic checkbox. I don't know. It may need real customer usage to see what they think, and if they catch on right away, then okay. But I want it to look clickable. I mean, the button looks horrible. Let's just take the button off for a moment and see what happens. Okay, I don't know if we need the frame. Yeah. Okay. Oh, that's quite reasonable. I don't really want that overlapping the diamond, but it's enough I can think about. This clicks, that clicks, that clicks, that clicks. It's like my vertical line should be in two parts, shouldn't it? One up to the top of the diamond and one to the, down from the bottom of the diamond to the next line. Or make my diamond not transparent. Is also reasonable to me. All right, let's do that for now. I mean, we can always go back to a button if it seems right. Okay. X scale times a half. I wonder if I take this out. Yeah, it didn't matter here now. Okay, so it's got its own position as X and Y times the connector center. Can I give an image a background? I guess I could. I could make a Z stack with white and overlay. Well, let's try that. Color.white. I don't know. Maybe I'm worrying about something. Image inherit from view. Image is a view. I'm pretty sure of that. Because kind of everything is. Everything SwiftUI draws, I should say. Well, here I am wrong. Okay, it's... You want to add images to your app. Okay, image text. They say it's just a struct. No, I don't think that's going to help me. That's all stuff images can do. Foreground color. Well, maybe I could set the background color. Okay, let's try that. Let's try something that make it obvious. I'm choosing the wrong color, but that's for. Let's try this. Yeah. Okay. So it gives it a little clearance around there. I don't think that's unbearable. What did we see otherwise? Oh, the line went all the way through. Yeah. Okay. So it's the image itself has that pixel of white, maybe? It's not coming from the line, so it's got to be coming from the background on there. Okay. I think. Let's see. Sorry. Remove the 0.25. Yeah. Good idea. Oops. Radius percent. Okay, so if I take this off, huh? Sorry, where's my cluster? I think. Let's see what that does. No, the vertical lines. Oh, you're right. You're right. You're right. Okay. Right. Because that's the parent that's drawing that thing. Huh. Yeah, that might be a way. Okay. Let's see. Can we do it in 2 loops? Well, in a way, yeah, I mean, I'm sure we can somehow. This cluster, though, it's like draw the cluster for the connector. And it's, oh, wait, I know what I can try. No, that won't work. I keep forgetting we're drawing after. I was going to put more padding on it, but that's not the problem. The problem is that line should just be shorter by the length of the connector. And even, I guess if I draw it in 2 loops, I'm sort of relying on the background, redrawing the background over top of it and letting that give it some room. Okay. I think I'll take the problem as something to address later. Again, I think I'm going to flip these things around so the stuff's on the other side, and I've got a feeling some of these things, like this code, is probably because of that flip and stuff like that. And if we flip that, I think all of a sudden it just sort of works. Yeah. We'll simplify some of this and not need so much. I don't think it will solve the cluster problem, but maybe we're doing something wrong there. No. Oops, it's a function. Okay, now I'm going to take those quarters off and see what happens. Well, okay. Nope. Okay. All right. Well, it was a thought. Okay. I'm going to save that problem for another day. Let's see. So I think what's still kind of bugging me, the scale of these things is, if they really are 0 to 1 and 0 to 1, I'm sorry, x is 0 to 1, I believe. We'll have to check our function. Well, it's not really, is it? Somebody's got to figure out what the scale is of these levels and decide what the scale is. This one, the y, this is really counted in line widths, or line plus spacing widths. It's y is 0, 1, 2, 3, and then if you're drawing between 0 and 1, it'll be 1/2 of 0, 1. But the scale is all based on the vertical number of lines. And we do know that because it's the total number of elements, which we know. And so I feel like it maybe everything should be on this sort of, like, I want to call it a unity double. It's 0 to 1 or let's give it some name. This one is also that. And it feels like we get something out of that. I don't know. Let's see, what do you think? Clusters you get. Yes. Yeah. Could it get more than one? I think somewhere we've scaled it is what's going on. Level is increasing. Where is level computed? Not here. Is it in cluster? Distance from one number to the other. There's that minimum element distance. Okay, element distance is passed in. Okay, but what's level? Right, who creates the cluster? Here it is. Level is distance. Okay, yeah, so maybe it's not scaled either. Okay, I'm not as sorry. Which multiplication? The view, this frame width multiplication. Yeah, I mean, I think in ours, well, maybe I can even say it in here. I picked numbers, so I mean, it always is going to take the pair of elements with the highest, the most similar pair of elements, and their similarity matrix or similarity number is going to be that 0.75 there. So the two most similar, these two are equally similar, these two are equally similar. And then this pair of clusters is a percent more, and this one is everything. Those are hard coded. That is well, I guess we'd have to find our distance function to know. Okay, and this is just absolute distance. I could swear we scaled it somewhere. But yeah, I made up those numbers so they're hard coded and in the range 0 to 1. But you're right. I'm not sure there's anything that's going to force that in the algorithm. Oh, cluster. Well, cluster is the result of a clustering. So where it's created? This is the cluster created from two elements. Yeah, so this is a new cluster built from an old cluster, and it's the distance function, and that's passed in. Oh no. There it is. Okay. Min distance is the product. Oh, that's the cross product of the two lists of elements. Okay, so find the minimum distance among them. Okay, so it all goes back to your distance metric or this element distance function. And in our case, we've just been using subtract absolute distance, absolute value of the distance. So difference. Right. So in real life, maybe it can't be. Okay. I know why I keep thinking it's 0 to 1, because in the tune case, we're going to take, I thought we've done this calculation, but where you take a tune and you get its Parsons code, up, down, up, down, and then you take the next tune, and we're going to do some sort of vertical distance relative to the length of the whole thing or something like that. So it'll come out 0 to 1. I can't even remember where we've done that. Is it in Tune? I mean, I think I started down that path of computing those, but because the clustering algorithm was so hard for me to get my head around, I didn't want to try and do tunes at the same time. So I'll have to find it now. I mean, we're going to come across it again, and maybe that's okay to look right now. But somewhere I remember making these tests using the Parsons code on that stuff. Yeah, maybe I'll just see it when we get there. But yeah, so I made assumptions that we can take 1 minus the level. And so I guess back of this connector X range, I think is I think it's a 0 to 1 level. And I don't know, the characteristics of 0 to 1 levels, like if you subtract them from 1, it's still in the 0, 1 level. It's just flipped or something, you know. They're very handy in that sense. If I know I've got stuff that sums up to 1, you know, across the whole distance, then that's kind of nice. I don't know if that's the case though. We'll find out. Yeah, it wouldn't be that hard to scale it. I mean, we are scaling it right now by percent, the diagram percent, and by the frame width, you know. Because for now we know there's 0 to 1, then we can just multiply by those values. If not, we would find the maximum and maybe the minimum if it's negative, and you know, work it out from there. Okay, so I don't know. Let me look at where we are in connector. So connector, it holds the sequence number. I'm not sure what it ever does with that. It needs a hashable, equatable identifiable. So having public var ID of some reasonable type is identifiable. So we can throw those in hash tables and stuff like that. Level is, well, I'm curious who's using that, because we use it to put X and Y together now. Do we need it? Level. Oh, here we do. I'm not clear that it seems like we should be able to derive that from connector.top. Yeah, well, it's that same thing we did before. It's frame width times diagram percent times 1 minus level. Well, I think the 1 minus is going to go away. Yeah, if you could just draw this scaled in a 0 to 1 world and then scale it by X and scale it by Y for the whole diagram, I think that would be good. Yeah, we need to know it. Well, do we? I don't know if we do, because we know. I mean, I think I could pass in we have an on touch or something like that. I can pass in connector dot ID, which is the sequence number, or I could pass cluster in as part of connector, and say you've got the cluster selected and all its children or something like that. But maybe they need to be externalized. I don't know. We might need it for its own purposes. But I feel like most of what level is there for, so we know where to draw that starting point of the line, and that's already kind of embedded in our cluster top, or cluster.top.x, or connector.top.x, connector.bottom.x for the level number. And several things can be at the same level, so it doesn't really, knowing just the X wouldn't tell you enough. You need to know X and Y. But maybe that's okay. I mean, we could go down and ask them all. But I think if we can make it on touch on that image, as long as we can connect back to the cluster or to the tune, if it's an element, I think it'd be okay. All right. So I guess in my mind, I still have a gap here I know we need top and bottom, and I think we use center. Let's make sure. Okay, connector.center. Again, that seems like we could derive it from what we have. But connector.center is a good concept, I guess. We're not using it a lot. All right. Ask the center of a cluster. We care about that. And who cares about that? Who does use this? Oops. Yeah, so connectors uses it. It has nothing to do with the connector class. Maybe connectors should be the owner. Center. Connector center is really cluster center. Starting from starting row. Yeah, okay, I'll leave that a little bit of a question where that should live. There's no behavior on connector, which kind of worries me. I mean, this is not exactly on it since it's talking all about cluster. That strikes me as odd. It may not be. I mean, to some extent, connector is that U-shaped pitchfork or tuning fork kind of shaped thing. And we're just retaining the information we need to draw it. And then I think to your point, when we click it, we're going to need some extra information, either some entity in here that we can work with like cluster, or we have some other thing that knows how to get from sequence number to cluster and we pass the sequence number, that'd be fine. But something that says click on something and how do I know what to clear off? And to some extent, your notion that we should pull out the buttons to a separate drawing level or, iteration. The buttons they are the ones that need separate information to do their job. There's got to be some list of which ones are active or something like that, right? We somehow have to tell them. Maybe we know it from the whole connector set. And we can just say, like, select ID, if we knew the ID, and it could walk down through its tree and take everything from that ID and below. And that would work. Okay, so I feel like I like what we did on this. Let's keep track of that here. Okay, so one thing was we pull out connector and we pull out connector to its own file. We created connectors to represent array of connector, pulled to its own file. We simplified drawing with horizontal line and vertical line. We improved the buttons to be closer to final form, for what that's worth. Okay, and I guess I can let this tell me, right? we need to be at the bottom. 223. Well, we know the sequence number because we put that in here as the ID. So I'm thinking if you clicked a connector, we tell the root connector. I think we have to know something to tell the root connector, hey, highlight only from this ID down, and then we can walk down the tree, zeroing out things until we hit the sequence number and then setting all its children. So to some extent, if we can track that root connector, I believe we can use that to do that. How to get that over to the list of elements, I'm not as sure of, but we can ask. We'll have to get back to the cluster somehow to do that, I think. And we don't track cluster yet. So yeah, there's a gap there. Why am it's like I'm not in the right branch. Well, that's slow. I'm not sure what's up there. All right. At any rate, I think we made decent progress on cleaning this up. You know, a lot of it was kind of mechanical, but the result, we got rid of that level. I should say that one too. Eliminate element.level, unused. And all that to me seems a little better. I think we'll work on selection next time. Is that what we said here? Flip diagram horizontally. Maybe we should do that next time. And then work on selection. Because I think, well, no, it shouldn't matter. Maybe this would be better. It's more semantic. The dendogram horizontally flipped. I think that just simplifies our drawing code. I don't think it changes anything really. Okay. So move that down a little further. Oh, well, if we got that far, selected nodes pass through the filter. That would be very cool. Yeah, read from left to right. I think it's a better way to do it, even though usually, well, I've seen them drawn in just about. I've definitely seen him on the right. I've definitely seen him on the bottom. I've definitely seen him on the top. I don't think I've seen it on the left, even though I think that's actually the better one for us. The other one I kind of had in mind was maybe some color coding or bolding or something, like percentages above 50%. They seem really good, but I don't know. These are all getting above 50% here. It's hard for me to sense what's the sensible thing there. Maybe when we get real data, we can judge it better. But somehow I would like these very tall nodes like these that say we're really very similar. I'd like them to be a little thicker or a little color coded or a little something. But that's a future problem. I mean, we don't have tunes yet. We shouldn't really be tweaking the thickness of lines with redundant information that may be useful. All right. Thanks for joining today. I think we'll do selection tomorrow and see how that goes. I know I'm going to learn a few things because I've got some gaps in my thinking about it. But it's a slightly new paradigm UI-wise, so it's a little risky. But I think hopefully if I can get people to click the first diamond, then everything will make sense from there. All right. Again, Mudshark especially, thank you for your comments. And everybody else who joined, take care. Bye-bye.